Wow, the number of slides grew overnight.
Oh, only by like 30.
All right, it is 9 a.m. Woo! Good morning. Oh, look at that, just rolling.
Oh, there's
the
the
last
crew
second.
rolling in.
All right. Well, welcome. We are going to talk about configuration management and SALT today. As a starter, I'd love to see anyone who has loosened up their shoulder joints and moved around a little bit this morning.
Should we all get up and stretch?
Raise it.
Maybe a little bit.
I'd love to see how many people are using SALT, have used SALT at all. Hey, there's a couple. They're in the front row. Yeah.
And not this kind.
How many people are using some kind of configuration management? Okay, so bigger show of hands. Okay, so that helps.
I guess.
That helps the tempo of how we go through this. How much time do we need to review what configuration management is and how SALT does things specifically? We wanted to just go through a quick example, so rather than trying to use just words to describe what we mean by configuration management, which does a pretty good job, I think, of describing it just in the name, go through an example of configuring something with configuration management. So let's imagine that we have some kind of client reporting dashboard, a web app that you might use, track all your devices, and that information gets onto that reporting tool by the clients running a background task that submits that check-in data to the dashboard. You have to get that agent installed on the devices and running. So there's a number of perhaps incrementally more interesting solutions to how you do that. So at the worst possible level, you take someone you don't like and you make them go and install that package on every single device manually. Certainly, I'm sure we can all say we've seen this done. And of course, the problem is, like, you miss machines. That's a lot of work. And of course, a lot of Mac users are admins on their computers, so they can just turn that thing off if they know what they're doing. So we get to a slightly more advanced method for doing that, where at least somebody's not walking from machine to machine. We're going to let Monkey deploy that agent software onto every device. That has some advantages as well. We probably don't miss any. We probably don't make any mistakes. However, we still have that same con down there. Users are admins on their machines. That one's not going to go away. We can get a little more advanced, though. So using some of the other features of Monkey, we can go beyond just installing a package. So Monkey is going to look for a package receipt. If you just Monkey import that agent package, by default, it's probably just going to look for a receipt on the machine and make sure the receipt is there. Somebody who's going to remove that, probably not going to bother removing the receipt. They don't care about the receipt being on their device. They just care that they don't want this thing running on there. So we can use Monkey to continually detect, hey, is this thing running? If not, let's try reinstalling it. And then the final solution we have here is that maybe we can go a little bit further and use SALT to make sure that thing remains installed. And the advantage here is not immediately obvious, right? Because you can do the same sorts of things with your install check script on Monkey. The problem becomes when you've got more than one of these things that you have to maintain. So imagine that you might have two things that you might want to install on clients, and they both have launch daemons, right? You all of a sudden are now copying and pasting these install check scripts and post-install scripts and all this work back and forth and hand editing the values in each. And then heaven forbid something might happen, like you need to update all of your Python code to Python 3. The advantage with SALT is that somebody else is doing all of that work for you. So SALT, as a configuration management tool, has modules for doing simple things like making sure a service is running. And on the Mac platform, a service really means launch daemon. So let's talk about SALT in general. If you go to the SALT website and you want to start learning about it, they're going to describe salt in a way that we're not particularly interested in today, which is that you have a salt master, which is a server somewhere out in the world, and it pushes commands down to all the things you want to manage. They do the things that you tell it to, and then they send the results back. That's great if you have devices that are always online. They don't have batteries that turn off. People don't go on vacations or anything else. So what we're talking about primarily here is managing people's laptops. And for that, we do what we're going to call Salt Masterless, right?
Sounds good to me.
Sounds good
Ship
to you? So in this situation, instead of having a master that is pushing commands to devices, and really whichever devices are actively available at that time, we're going to let the devices just on a regular schedule run whatever states we tell them we want them to run. And one of the things that they do during that is go and check and see, have all the states that I'm supposed to run changed? If they have changed, I'm going to go grab them so that now I've got the latest information and I can run those again. So that's fine as long as that laptop can go and check the internet whenever it does have an internet connection, and it'll be up to date as soon as it's on. If it's not on the internet, chances are pretty good that person's probably locked in a trunk and no amount of repository changes are really going to help it be any more secure. So,
But we can fix that, though. Maybe one day.
yeah, maybe. So the way we set up Masterless is not something, again, that they really present in the SALT website or documentation about being, this is the main use of SALT. This is kind of like a niche use, I guess, in some ways. So it takes a little doing to understand, and I've kind of described the tasks for what you would have to do, right? So to get SALT Masterless running so that you could manage devices, you would install the SALT installer, which is just downloaded from their website. I've pointed out the Python 3 installer because we've got, 5 months left of Python 2 before its end of life.
Too long.
With plenty of time. You have to configure the minion, all right? So the minion is a process that runs on the client itself, and that's what's going to do all the scheduling and run all these tasks in the background. Once you've configured it, you need to start it, and then you need to schedule those repo downloads, checking for new states to run, and you need to tell it to run the high state. And high state is just, for whatever reason, the name that SALT gives to this process of, we're scheduling it, do these things, apply these states, this list of states to all your devices. So I use Monkey to do that.
I do as well.
Wes uses Monkey as well. There's certainly other ways to do this. I'm sure you could deploy it with some other tools, but we use Monkey. So Monkey, in its pre-install, writes the minion config to disk. It's just a text file. And it's pretty much unchanged from what you get stock. Just need to tell it, hey, we want to do masterless. We don't need a master. It installs the SALT package as its main payload. And then in the post-install, it actually uses SALT, because now it's post-install. SALT is available. Python 3 is available. PyObjective-C is available.
Oh, yeah.
We can do some things. So one of the things we're going to do is use SALT to start the minion's launch daemon. So now the minion's running. We're going to schedule downloading our states and our custom modules that we might want and have that start. And we're also going to schedule our high state runs. So we're going to go over some of the parts of SALT because every configuration management tool has basically the same things, but they all call them completely different things. They're themed, usually. SALTs are a little weird. But the big one that I think is important to talk about is that most of what we're going to be showing off today are modules. And there are a lot of different kinds of modules. The ones that we're going to focus on today are called execution modules, state modules, and grains. All right. Really, when we are managing devices and we're saying we want them to be in this state and we let Salt do all the work to make sure that they end up in that state, what we are using are state modules. So we're going to focus on those especially. Then we also have, confusingly, state files and top files and pillar. And we just showed a little directory layout here. There's nothing magical to this repository that the clients are downloading to manage themselves. They're just folders filled with YAML files, Python files. And each type of module has its own folder, and each type of file has its own place to go in that. It's pretty flexible, but it's also in best practice kind of codified. And it's worth pointing out that the ones with the preceding underscore is us shipping custom stuff. So you get all of the modules that come in the Salt standard library as part of the download. If we want to add on custom modules, which we're going to show a whole bunch of, then you have to put them into a place that Salt knows how to find them. And we, in our minion config, say, this is where you look for them. So if we want to put some custom modules in, we put them in underscore modules. And it has a whole search order for where to find that stuff. So modules in general in Salt are called modules because they are Python modules. So Python module is just a Python file that contains definitions of some kind. Functions, could be just variables. So just to show you, in this case, the Mac service execution module, which handles running and stopping launchd jobs. I mean, it's basically just shelling out to launch control. If you fold all the code, this isn't all the code, but this is a good part of it. This module exports all of these functions, and these functions can be run from the command line to do stuff. And the execution module specifically will do things one time. And any function that has a name that doesn't start with an underscore is exported by Salt, and it's now available to be used on the command line. It's available to be used by other modules. So Mac service.enable, for example, would enable a Mac service, and you can see the attributes with it. So modules in Salt do a lot of different things. They can affect or report on a managed system. Examples include copying files, managing their attributes, installing Python packages. We're going to look at a bunch of examples of those. But I think one of the tricky things that I wanted to highlight that took me a little while to really grasp as I was exploring all the different configuration management tools was this concept of execution modules versus state modules. And like I said, Salt has a lot of other kinds of modules too.
So many.
Grains are a module, there are beacons, there are returners. We don't need to worry about all those today, but the big ones are execution modules and state modules. Execution modules are do things right when you call them, and they do it one time. So in that launch control example, we're saying start the service. Great, it starts the service, and then it doesn't do anything anymore. But there is a state module that corresponds to Mac services as well, and states allows you to say, I want this thing to be happening all the time. So a state module for that would be Mac services.running, right? They use different parts of speech in English to help make it obvious that the execution module does a run thing, but the state module might have a different name like .managed, for example, or present, rather than just copy it. The example I put on the bottom here is host name. I think everybody's probably been able to read that, but it helps differentiate the execution module. Hostname.set sets the host name of the device one time. Hostname.manage ensures that the host name is always what is specified. And the way it works behind the scenes is that it actually calls, the hostname.manage state actually calls the execution module. This is just really to minimize code duplication. It's very smart. So, if you run that hostname.manage state, it's going to actually say, let's use the execution module and get the name of this device. hey, that's not what I told it to be. It's supposed to be hyperleet. So now I'm going to use the execution module for setting a host name. And then I'm going to check and make sure that it actually set, and I'm happy with that. So at the state module level, all you've said is, I just want this name to be this. I don't care how you do it. Somebody else has already done the work to make that happen. I'll stay here for a second so you can get that Macho Man picture. So all that being said, mostly what we're interested in here are state modules. We're not using a master to push one-off configurations down to our devices. Like, oh no, let's do a one-time, hey, we need to delete Zoom off of all our devices. We might want to say, we want this to always be gone no matter what for the rest of time. So we're going to be dealing with state modules. And just going through the rest of the kind of terminologies, grains are another kind of module that we use. Grains calculate things and figure out data about the device itself. This can be kind of tricky when you're also looking at pillars, which are also data. But grains are little Python modules that will run and tell you things like, what's the product name of this device? It's a MacBook Pro 15.1. Here's an example of a grain module. It is a 2-line Python function in this case. It's just a Python function that returns a dictionary. The key is the name of the grain, and the value is whatever value you want it to have. State files are where we use the state modules to describe the state that we want our devices to be in. It's how we configure things. And again, that's what we're going to be looking at primarily today because we want to configure our devices. So this is just one state cut out of a file, enabling the files on demand feature for Microsoft OneDrive, making sure that it's on, right? So the first part of the state, it's all in YAML, yet another markup language. The first part of it is the name of it, and that will be displayed when you actually run the high state or when you report on this and you look at the logs. It's going to tell you, here's the name of the state. So the best practice is we're going to name it something that reads as helpful English language of what this thing is going to do. Then the next thing that we have below that is the module and function. So just like any kind of Python method calls, we're going to use dot notation to find the module and then the function that we want to use. In this case, we're using the preferences module and saying we want this preference to exist. This is a state module, so we'll make sure that it always has these values. And the rest of it is pretty self-explanatory, all the parameters for setting a global level preference. We also have this top file. And this is a little bit confusing, and we don't have to get it all perfect, but we'll just mention it. The top file is a way of saying which of all these state files, you could ship 2,000 state files if you really wanted to. The top file is where you assign those states that you want to apply to clients to actual clients. And you'll see this thing called the target in there. The environment part we can avoid. We don't even need to worry about that. The target, in this case, we're just saying we're looking at a grain. We want to target all macOS devices. They're going to get these states, keyloggers, security, sweet games. You can obviously get a lot more in depth with that. You can do it by serial number. You can do it by any grain data that you might have. This is running on the client, so they will process this and apply the states that you think they need. The final part of SALT that I wanted to show was pillar, and that is just data. And like I said, the grains are running Python code on the client to detect stuff about the client. The pillar is just static data that you've given in the repository, and it ships with it. So these are just some examples of, there's management exceptions. Here's a couple serial numbers that we might want to use later. Here are some preferences that we might want to set. It's free form, whatever kind of data you might want to ship. And then just felt obligated to put the configuration management terminology, pseudo disambiguation cheat sheet up. Nobody that I've spoken to can even agree on this. Don't take a picture of that. Because it's probably wrong, and everybody seems like they tend to gravitate towards using one configuration management tool. And as you get more and more into the depths of how that works, it also gets harder and harder to remember what all the things were called in Ansible that you haven't used for 3 years or whatever. So it's probably wrong. But just to give you a little mapping, since it seems like everyone here almost raised their hand when they said they've seen some configuration management tools. So what kinds of things would we even want to manage on a Mac? Preferences are one of the big ones. I said regular old config files, right? Like hosts or SSH config. They're all different formats that kind of predate a little more structured things. We have tools that the OS gives us, binaries that you can run, like the security tool that we could shell out to potentially, and we can wrap with modules in Salt to be stateful, or even just data like wallpapers, or your corporate trust store. We'll look at that in a little bit. We can also manage what kind of tasks are scheduled on your devices. And then really anything you can dream of that you can get to through Cocoa. So we have PyObjective-C shipped with the Salt installer. So we can get right into all that stuff from Python. We're going to look at what comes with Salt first. And I just have this quick slide in here to remind you that when we're talking about state modules, what we're showing are state modules. If you Google or use some other search engine, you weirdo, you're going to look for, oh, how do I do that thing again? I'm going to look for the Mac services module. You might get the execution module documentation. You're going to be super confused while you're looking at it. Make sure that you're in the state modules section. And just again, bringing up that difference between execution modules and state modules. When you are describing the state that you want your devices to be in, you are using state modules. So one of the ones that does a lot of work for us is the file module. It does things as far as creating directories, copying files. In this case, this is kind of a change the details to protect the innocent, but this is something that I deliver where we have a lot of Python developers internally, and they need our root certificate and signing certificates in a cert bundle so that when they're doing web requests in Python, they can trust that SSL traffic. They don't have to go and keep that on file. They don't have to copy it around into all the repositories. I put it in a standard place for everyone. So the interesting thing here is that this file, that our cert bundle, does not reside in the repository. The state does, but it's going to grab the actual bundle from S3 bucket and copy it down into place. So file.managed, we're just saying we want this file to always be in this place on the device. Likewise, a lot of our developers are developers, and they like to try and change things on their machines. And so we have to make sure that they don't change the ownership of Monkey's folder. So Monkey does not get real happy about that. So this is a little more involved, but again, we've given it a really clear name at the top. We want to make sure that the directory ownership for Monkey is correct. We're using file.directory to make sure that that directory exists, that it's owned by the root user, et cetera, and it's going to recurse all those changes down. So if somebody comes and uses brew or something and blows up the ownership of the user local folder, it's going to come back and fix it. Moving on to the next example. I'm sure a lot of people here have used Slack. We also have Microsoft Teams. We're Microsoft Shop, so we use Teams for all our collaboration inside. Both of those love to complain if the app is not owned by the user who's running it about background updates, asking you to authenticate all the time. So I go in, and because all of our laptops are used primarily by a single user, we make sure that even though Monkey is installing Teams and installing it as root, we're going to go and then fix that and make it owned by the person who owns the device, so that that Sparkle updater doesn't nag them all the time and make them update. Especially with Microsoft Teams. Does anyone use Teams in here? Yeah, you can't manage the update checks or how it does that, how frequently it does it, or anything else. So it can be kind of a pain. Can you? Is that new? Oh, I thought I was getting some dissent. Some grumbling. Quiet down back there. So the service module is another one. So a lot of us use Nomad. I want to make sure that Nomad is running. So not only do I have the plist file for that available as a state that is managed into place to make sure it's always there. And you'll notice that this slightly out of date syntax is saying you need to watch for this other state. Make sure that once you've completed this state, making sure that the file is there. I want to make sure that this service is enabled. And so that's about all you have to do is make sure that this service is enabled. It'll make sure it's always running until the next salt run. It'll check again over and over again. This is taken directly from the salting procedure itself, where we configure the minion and kick off Masterless on the devices. We're using archive.extracted, which is another state. You'll see the source. Again, we've got all of our information as a tar.gzip file up in S3. The clients will download that. Well, first they'll check a hash, see if it's changed. If it's changed, they'll download it onto the machine. They'll extract the archive, and now they've got all those states that we want to run, all of our custom modules. So to update all the clients, all we have to do is push a new gzipped tar file up to the S3 bucket. You got to get through version control and everything else. But likewise, we have the schedule module. And the schedule module is what we use to actually schedule how the clients check in. When we run Masterless, it has to do this on a regular basis. So we use the schedule module. We just say schedule.present. We want to run this thing every 30 minutes. We can create a random splay around that so that not all of the devices are doing it exactly the same time of day. We can specify what kind of information we want to collect as a result of that. Like, do you want all the log output? Maybe. You might want to ship that off to that reporting dashboard that we talked about earlier. Similarly, this is how we schedule the Masterless repo download. It's the same thing, schedule.present. Every 60 minutes, let's go check and see if that hash has changed. All right. We don't need to worry about all the details and parameters of all these, just thinking about like what are the kinds of things that we can do with configuration management. Like what is it about this that makes it worth doing? The system module is another one. So you might want to make sure that SSH is turned off on a regular basis. It's not just hanging open, waiting for people to connect randomly to it. So you can just say system.remote login. It's off. Now we get into things that are a little more interesting. Managing things with third-party modules.
What is happening?
It's really easy to write your own modules, and we're going to go into that pretty soon. But the process for getting custom modules into this is literally just copying the Python file into that underscore modules folder. If it's an execution module, underscore states, underscore grains, any of the other kind of modules. We put that into that tar gzip repo up into our S3 bucket. You have yours in CloudFront, right? The clients will then get it, and now they have access to those modules. They can call them from states. So we have a few different sources for these things. We've written a bunch. Mosen's written most of everything else.
The Godfather.
The Godfather. And like I mentioned before, one of the really nice things about Salt that is an advantage right now is that it ships with Python 3.5, soon to be 3.7, and it comes with PyObjective-C in it. You don't need an internet connection to install it. The actual files are there, so it's ready to go. So we're going to go over a few of these modules. You might want to likewise make sure that Apple Remote Desktop is turned off because you don't want your devices just, again, wide open to the world, inviting people to control them. Or you might have a kiosk machine that doesn't need to be controlled at all. You can target different machines with different states, but we can, with these custom modules, say things like, we want ARD to be managed, we want it to be disabled. Yes, sir?
Are you able to do the opposite and enable remote desktop actual control?
I'm trying to remember. So with the changes to turning that on these days, Yeah, you can't have a synthetic click on it, right? So, good question. Don't leave it open all the time. I think it's the better security posture, but to be determined. We have a preferences module that goes straight through PyObjective-C to do CF preferences setting rather than shelling out to defaults. So we can do that to write any kind of preference that you may want. This is just an example. It's getting a little more involved. We're using Jinja to loop over some things, quote some things. But in general, we can ship some of these preferences. For example, we showed earlier a pillar. That pillar is getting used here. So you can see it's iterating over the values in that pillar and setting those preferences on for Nomad. You can also manage profiles for now. That might change, I don't know. But you can certainly ship a profile file, and you can also dynamically create a profile. That's what this module example is showing. It is actually creating the module, or creating the profile and installing it in place. And you can see where it says if display Mac and grains, ask for password is one thing. So it's actually dynamically creating that profile on the fly. It's not just a static file that's in the repository. It's templating that out. We can turn off or on Bluetooth if we really want to. And then we have a few modules that Mosin hasn't written. So pretty common task is installing the Xcode command line tools. You can have that as a bash script in Monkey, or you can have Salt manage it. There's a module for that. Let's see. Yes, crypt. When you update the OS, sometimes the information in the authDB gets dumped out, and crypt isn't in that list anymore. So we can use configuration management to make sure that it survives that OS update and puts that stuff back in. We can manage the host name if you're into that sort of thing. And not just the computer name, but the local host name and host name. We can make sure SIP's enabled. And Wes now finally gets to talk.
Yeah, thanks, buddy. So one of the other modules that we wrote was basically a simple wrapper around managing kexts. And since, kexts are, the future is uncertain, thought it'd be fun to write one of those. But the one that I really enjoyed the most, and thank you, Frogger, for helping me with this one a little bit, is actually managing Wi-Fi. Basically, you can manage where the Wi-Fi is in the list of the preferred network list, right? You can enable them, disable them, the auto join setting, and then you can move them to the top or the bottom, and then you can also remove them if you like. And as you can see here, we basically want to take AZ Wilderness Brewing, and we want to move that to the top. Make sure it's always at the top, and make sure it's always enable auto join. I was actually just in Arizona, and this was one of the Wi-Fi names that was on there, and I was like, that sounds like that's a good idea for the presentation. And then we can make sure that the days in downtown Wi-Fi is at the clear bottom of the list. And then we only want to disable days in downtown if the Arizona Wilderness Brewing SSID is already in there. So if it's not, then don't disable it. And then, you shouldn't be using the PSU wireless setup here, so we just want to get rid of that. And then iOS is my tethering, so we don't want that in the list anymore. And then don't remove any of those unless, of course, we have our Arizona Wilderness Brewing. And doing the thing that nobody should ever do, a little assault over the left-hand shoulder. Good luck. Demo time. Okay, so as you can see, we've got days in downtown at the top, auto joins enabled, PSU wireless is in there. We don't want that. iOS is on there. And AT&T Wi-Fi. I'm sorry if you can't see that. Probably can't make that any bigger. But so we're going to run the state that we just showed. And we'll do that by... We're going to apply the single state. That we can make bigger though. Yeah. And we'll run it. And this is where I hope I can type in my password correctly. Oh, hey, first time. Look at that.
It's impressive because it is 32 characters.
So it's basically going through, and it changed the Wi-Fi on all 6 of those states that fast. And then, as you can see from the output, like here, we successfully removed iOS from the preferred network order list. It was available before, now it's removed. Here, days in downtown, auto join was, or it is now disabled, but it was enabled before. And then we also, it was 55 positions in the list from the bottom. But now it's at the bottom. So that's kind of cool. And you're like, well, that's probably just a bunch of magic, and that never actually worked. But as you can see, and I didn't even have to refresh the preference pane. So as you can see, Arizona Wilderness is now at the top. PSU Wi-Fi and iOS aren't there anymore at all. They're actually here. This is a fun UI bug, but if you refresh, it goes away. And days in downtown is at the bottom. So, hey, what do you know? Live demos work. That was cool.
I have been actually asked to implement basically the same thing as we transition from one SSID to another. So there's absolute use for that sort of thing.
Yeah, and then this all just doesn't matter if you have iCloud turned on, and it uses the keychain from your mobile device. So that's great. All right, next. So you're like, wow, that was really cool. What if I want to manage something else? Well, good thing is, oh no, actually, this is you.
Yeah.
Yeah, you get to write your
It's
own
back to me.
modules. Yeah.
I promise I'll let Wes go for a while after this. I think one of the things that is scary about this is that there's lots of stuff saying, oh, you just need to know a little Python. It really is a little bit of Python. I wanted to show an example of taking a task that I had in Monkey and how I converted that into a salt process. So one of the things that we need to do is we have offices all over the world. We use Sal to report on those. It's a pretty great project. About to be version 4. Wink, wink. And each of those sites has its own machine group. And the way Sal reports into those different machine groups and sends the information from those devices into those machine groups is that each machine group has its own key. So on all the clients, they need to have that key to help it send its information to Sal and say where it needs to go. So the Monkey process was a giant install check script and then a nearly duplicated giant post-install script. It's no package item. So if we look at what's actually being done here, that does a few things. It has to process something to figure out what site that device belongs to. It needs to use some kind of static data, like a table, to associate what that site is with a key, which is just meaningless garbage characters. And then we need to set some preferences. So these map to things in Salt pretty easily. So processing something on the device to figure out which site it's in is going to be a grain. The table that associates the sites with their keys is in Pillar. That's data that doesn't change based on the device. That's static. So that's a good candidate for using Pillar. And then we need to set some preferences. So we would use the prefs.exists state module. So we can make a grain really simply. This is kind of simplified version of processing on the client through the monkey scripts to figure out which site it's on. To change this into a grain, we just put it in the grains folder, and we just need to change our return. So before it was returning a string, really the grain just needs a dictionary. So that's really pretty easy. This is Python code that I already had. So it took about 1 minute to convert it. And then you use it in your states by using Jinja to template it in, which I know is a little bit hand wavy, but we've been seeing lots of that so far. We need to move the table of, and I just put pound signs in, but this would be like big long hash values. We need to move this table into pillar. So the pillar data now is just changed from being a Python dictionary to being a YAML dictionary. And again, we can template it in with Jinja. And then finally, we don't need to convert all the preference setting code. And this is where the big advantage happens, because I have a number of different things that need to set preferences. I can use the prefs.exists module, which has that code in one place. It does a really good job of exception handling. It doesn't blow up and just die, hopefully. But I don't have to copy and paste that script into every single monkey item that I want to set preferences with, for example. So we just use the prefs.exists module. So the state just looks like this. We use the prefs.exists module. We say we want to manage the cell open source domain. We want to set the value to, here's our pillar dictionary, and we're looking in that dictionary by using the grain that we've already calculated. The grains run, every grain that is shipped with your device and shipped in the repo, every high state run, it runs all those grains. So they're available for your states to access. So you don't have to run the grains. And I believe this is you, Wes.
Oh, yeah. So you're like, cool, that's all fun. But like, I have this unique use case that came up at work, blah, blah, blah. Sol doesn't do it by default. Like, how can I like just put this into like the rest of our states in our code, and make sure that works? So you can write your own custom state module. And like you said it once, we'll say it again. States are easy to write. It literally says it in the documentation. So if it's in the documentation, it's got to be true. But they're easy to write if you know a little bit of Python. And the template for writing a state module is like, it's very boilerplate. And they give you a nice example, like in the actual documentation. So we'll take this example, not really, and what we're going to do is we'll show you how I wrote this kex module. So here, we're basically we're going to see how kex.running actually works underneath the hood. So, all right. So custom states follow a workflow. It's pretty simple. It's basic item potency where you first check to see if we need to make any changes. Like, is the device how we want it to look already? So if it is, then we can just exit out and we're all good. The second one is a nice little test. So if you're like testing these states, you don't want to just always like, well, yeah, run it, do it every single time, especially if it can be like slightly destructive. So you want to put a little check in there to see if you're passing like the test parameter to the run. And then last but not least, cool, it's not in the state that we want. Let's put it in the state that we want. Let's make it how we want it. So back in our repo, you basically need two different modules, one state module and one execution module. Let's take a look at the state module. Documentation is big, so Python uses Salt uses doc strings. So at the very top, basically a quick example, like if you're sharing this and somebody else wants to use it, you can like look and see, and this is like a basic example of how it actually works inside the doc strings. Pretty simple Python. We're going to import the platform module and import the logging module. Just default Python modules, and we're going to set up our logger. This is like all in the example. And then next we'll take a look at the virtual name and the virtual function. So Salt doesn't just run on Mac OS. It runs on multiple platforms everywhere, like Windows, Macs, Linux. And instead of like having a version for every single one, or you don't want it to accidentally run on platforms that the code like doesn't necessarily work on by accident. So with this, whoops, too soon. Go back. Here we go. Basically, what the virtual function will run before it runs anything else in the module, and it's like, okay, is this machine that we're running on right now Mac OS? If it's not, return false, like this module is not available on this machine. Like nothing in here is going to work on this platform. If it is, then return the virtual name that we set up top, which is kext. So, and you're probably like, well, the name of the module was mac_kext. This is a shorthand way to tell when you're defining it in a state, what it is whenever it gets called. So, as you can see, it's kext.running. And the virtual name is kext. So whenever you define kext, it goes through and it looks for a state with the virtual name of kext. And then we're saying, oh, we want to use the function running. Let's go through and then let's find the function running. And that's what we'll use.
I think it's worth pointing out too that, again, to this point, it's all boilerplate.
Yeah.
It's not like Wes has to figure out how to do this each time. It is like copy another state and edit the name.
Yeah, simple find and replace, if you will, for some things. And then here, like the parameters that you put in the state file are literally just passed into the actual function. So in this case, name, which is going to be the path to the kext, like where is this kext on the system? And then the bundle ID is the CF bundle identifier inside the actual kext. All right, so let's get into the fun stuff, which, more documentation. Always document your stuff. This basically says what does this function do and what are our parameters and what should they be. So Salt knows, so it can know like what is happening inside of this actual function. You set up a return dictionary. So we want to know what the name of this state is. Like, was the result of like us doing things, was it true or was it false? Did we make any changes? Like, did we change foo to bar, or was it already set? Are we good? And then a comment, a nice little like human descriptor, human readable of like, what did we actually do? And like, is it okay? So first thing that you want to do from our little list before is check and see if what we want is actually the way we want it. And we're going to do this by calling the execution module kext.running. I know it's a little confusing. There's like a running here and there's a running there. But this is a Salt, when it compiles in the very beginning, it gets a list or a dictionary of like, here's all of the modules that we have and all of their functions. So we're saying, look through all the execution modules that we have and call the kext.running execution module and pass it the bundle ID that we have. So that goes back to where we were like in the very beginning inside of our repo. Then let's take a look at the mac.kext file in the actual execution module. So execution modules can be called from the command line if you want to test stuff. It's super easy. Let's take a little look. So basically, all this is doing is just shelling out to kexstat and saying, give me a list of all the bundle IDs that are like actively running. And then we use the, Salt has a nice little wrapper for running all sorts of commands. But we want to say, like, let's run this and let's get all the output we can possibly get. So let's get the standard out, let's get the standard error, let's get the return code, and like any, well, pretty much just that. So when we run it, if the return code is something more than, like, if it's not 0, then we'll return with the information like, hey, this failed. But say it's good, and like, okay, we have our standard out of the command that we ran. Is there actually any standard out at all? If there isn't, then we probably don't have any, we have like no kex running with the name that we passed it. So we can immediately return false. But if we do have output, let's throw it into a list and loop through it and look to see if our kex is actually there. If it is, we can return true. And if not, we can return false. Pretty easy, right? True or false. A little bit of Python there, but. So back to our state module. So we now have the output of running the execution module to see whether or not the kex is actually loaded and or running. And we store that in kex.running. So if kex.running is true, that means we already want this to be running, so we're good. We can exit out. We're good to go. So the next thing on our little list was to see, like, are we running as a test? And this is a simple, like, there's a options under dictionary of like what was passed in. And if test is in there, then the result will be none. We're like doing just a simple test. And we'll actually want to, if like we kept going, we would actually start and load this kext. So if we're not running as a test, then hey, guess what? Let's start it. We're good to go. Just run the kex.load execution module and check the return of that. If it was false, then we can return false, like say, hey, we failed to start this. You know, it couldn't be where we wanted it to be. You know, a number of other things. It could be on a future version of Mac OS. And then if we didn't fail, then we're good, and we can say, hey, we successfully loaded this kext, and the old, it was dead, it wasn't running, and the new is, well, it's running. So what, 80 some lines of Python? And if we run it, and it wasn't running before, it's actually running, and it took, what, a second to run? Pretty neat. And you don't have to like do anything else. It's all like built in. It's using all the like the state features of Salt in the config management piece. Not too shabby. Okay, so let's move on to something else. Managing your MDM with Salt, and you're like, wait, what? We're gonna manage MDMs now too? Yeah, we're going to manage all of the things. So how do we do that? So Salt has a feature that are called proxy-minions. So, you know, they're all excited. So proxy-minions are made for devices that can't run a Salt minion or like an agent. This is primarily used for like network gear. So switches and stuff that you can't run an agent on. That are mainly controlled through an API. There's one downside. Unless it's like popular network gear, you probably are going to have to write your proxy minion on your own. Like the, let's just say like the truck that like runs everything is all there. You just need to write all the good stuff that it'll actually do. It was actually funny, in the proxy-minion documentation, it says you probably can't manage a house cat with a proxy-minion, but it would make a good thesis paper. All right, so let's go over like how these things actually work. So our normal setup, like we had before, we've got a bunch of salt minions, those cute little laptops, and then we have our salt master, good old Xserve. And let's make this way more cute. Oh God, Crew, what are you doing? You're on your side. Get back. Okay, there we go. It's a little bit better. Because computers and servers is like pretty boring, but cute little minion figures makes this way more entertaining. So normal salt master, salt minion. You're like, okay, well, where does our proxy minion come into play? So proxy minion is basically another server that you have. These aren't laptops. This is another server that's probably running in. You could have it running in AWS or like wherever you want next to your salt master. So the salt master does one thing, and it just like tells minions what to do. So the proxy minion will tell other devices what to do via their API. And just because cute, this guy's going to be our proxy minion. So the salt master will know, like, hey, we're going to give you, here's some of the states and the modules that the proxy minion needs to take care of, and here's the keys to talk to our MDM through its API. And in this case, we're going to use micro MDM, open source world, fun, Groob, you're great. So the proxy minion is going to talk to the MDM via the API and say, hey, give me all of the profiles that are on all of the devices, which is probably a lot of data. If you've got like a bigger fleet, but smaller machines. And then the MDM will talk to the endpoint and say, hey, give me the profiles that are on your machine. And then the endpoint's like, okay, well, here they are. Gives it back to the MDM. And then the MDM returns to the proxy minion. So we can use the same logic that we used locally to generate like those dynamic profiles and install it, like setting the screensaver for Pied Piper. But now, like say, we want to do that through an MDM, we can still have the same dynamic logic. And, for cute's sake. And so just to be clear, the endpoint does not require Salt to be running on it at all. It can literally just be MDM. So when we get that profile back, we can take a look at it and be like, okay, is this profile either A, installed, or B, is it the way we want it to be? Because, every once in a while, like you want to change a profile. You might like add something to it, remove something to it. And like MDMs, bless their heart, don't always install it every single time. Like sometimes they're in a pending state. This way we can check every single time, like, is this profile on there? If it's not, okay, like we need to fix this. Let's install the right one. So then we send the MDM from the proxy minion our new profile, and then we tell the MDM, install it on that endpoint. And, that's pretty cool. So you get the same perks of like dynamically generating profiles on the machine, but you're not doing it on the machine. You're like, well, why wouldn't I want to do this locally on the machine? Like, why would I want to use a proxy minion to do this? There's been some like whispers around of like the uncertainty of profiles, the install command of profiles locally, like on Mac OS. I highly recommend checking out Appleseed. If you haven't already, it's like super easy to like get to now. It's like all you need is an ABM account. Please go check it out. And then like another, like also why would you want to do this? You have all your endpoint configurations in one location. It's all in your code. You don't have to like log into the MDM and be like, all right, let me click a few buttons. Like, is this going to actually assign to the right one? Is it actually going to install? And then, we also get like, hey, yes, this profile is always installed and it's the way it should be. We can dynamically generate them. And then if you're on a team, you don't want somebody just like randomly changing a profile, without making sure, review from the rest of the team. This is all in code. So what else can you do with a proxy minion? Well, pretty much do whatever you want from the MDM protocol. You only get so much information about the machine. So by default, if we're going through an MDM, we can get like the serial number, the OS version, like the build number, some host names, what applications are installed on it, and what certs do we have. Like, that's fun, but like, what if we want to do something more? So if we want to do more things, we need more data to make decisions on like what we want to do to the device. So if we had more data, like say, like, is this like service actually running? Like, is this launch daemon running? Is this like other app installed? But like, where are we going to get that if MDM doesn't have it? So if it's not in the MDM spec, to just pull it by default, I'm like, please file a radar, feature request, better. Hey man, dude, way to ruin my joke. Apple employees, man. Man, I just like totally ruined the whole thing, man. So if we wanted right now to, via MDM, to check like, hey, when's the last time Monkey actually ran? The MDMs are like, come on, I can't do that. I have no idea like what is actually happening on the box. So like, where can we get that information like from the device? Like, where can we get that if it's not through MDM? In this case, our MDM is like very smart, and it says like, maybe we should check OS query. So, okay, wait, what's an OS query? OS query is a tool that runs on the box that allows you to ask questions about the device. And you do it in SQL style queries, and it runs on a whole bunch of different platforms. And then you can send those queries to a server. So if we have another server that has all this information, then like all of our servers can talk to each other and they can share all of this data. And there's zero need for the device to actually talk to our proxy minion. We can gather it from other places. So in this case, we're going to run a simple query, like from the monkey preferences, when was the last time it checked and ran? So our proxy minion will talk to our OS query TLS server or wherever we send that data, and is like, okay, when was the last time Monkey ran? 72 hours ago? Whoa. That's way too long. And if the device is like actively running and we can check it, and like OS query is actively running, 72 hours, that's, I don't know. All right, we should probably fix it. So through the install applications method of the MDM protocol, we can send the package, we can give it to the MDM and say, hey, reinstall Monkey on this endpoint. And I mean, I think that's pretty cool. So yeah, that's proxy minions in a nutshell. I know it's a very like wide overview. It's like very hand wavy. It's something like I've been actively working on recently, and it's quite fun, and we're pretty excited about what we can actually do. But so you know how it was the Mac endpoint? What if that was like an iOS device or an Apple TV or an iPad? You could use this same methodology for like profiles. So technically, you can manage iOS devices, you can manage iPads with Salt and the lovely proxy minions. All right, well, so recently Salt started this, the company, started this thing called macOS, or they started working groups where people that are interested in improving the actual product for like specific parts of it. Shea and I are on the macOS working group, and there's some others in the room that are also in the group. And we meet up once a month via Zoom. Ooh. Okay, maybe we'll change that. No. And we talk about what's broken with it, what can we fix, what are new features, what can we add, and all that fun stuff. All right, so for a recap of this entire presentation, minions are cute. It's basically all you can walk away with. The proxy minions don't require a salt minion to be running. That's like the whole point. There is no direct talking between a proxy minion and a salt minion. And any configuration manager is great. We just think salt's a little better. And Illumination, thank you for making all those cute proxy the cute minions. And yeah, cool, we're done. And yeah, Q&A. And that's the default stock photo in the Q&A for Keynote. And we're like, yeah, might as well leave it. So questions, no comments.
I'll let you handle the box.
No comments, please, but questions are definitely welcome.
I actually have a comment.
Comments are over beer later, Shea. Anybody? Anything?
While you're formulating your question.
Oh, yeah.
I did think, one of the nice potential uses of the proxy minion is, heaven forbid you should have to change your MDM at some point. If you abstract as much of that as you can into code that describes the state that the proxy minion is handling, then you have to swap out the API wrapper behind the scenes to a different MDM. Hopefully that saves you from hours and hours of clicking on things in a web UI that you may not care for particularly much.
Brilliant.
So it's another
use. And to the best of our knowledge right now, you can do this. You can use a proxy minion with an MDM that exposes the API and allows you to make those types of changes. Like, can you create new profiles through the API? And then can you actually tell the API, push this profile to this particular device? We use micro MDM because it's all open. Everything's good. To the best of our knowledge, AirWatch is able to do this. And you said Intune?
I see it in the API guide.
It's in the API guide for Intune. If you're using a different MDM vendor, I would file a feature request if you have any interest in doing this at all. Otherwise, it's useless information. And thank you for sitting through 60 some odd minutes of this talk. Any questions at all? Really? Not one? Yeah, there we go. Oh, yeah, move the drinks out of the way. You want to throw it or should I throw it?
No, go ahead.
Make sure it's on.
Sports.
Oh, see? That's, yeah. Sports. Oh, you can throw it next time then, Nate.
So all the macOS...
Is it on?
I don't know. I think so, yeah.
Okay, cool.
All the macOS configuration management was masterless, but with the Minion system, you talked about needing a server.
So all the documentation for Salt and proxy minions says master. And what I've been messing with it, I think we can take the same masterless methodology and have the on the proxy minions, there is a Salt minion running on the proxy minion as well, so you can keep the proxy minions updated with the latest info. And you should be able to use the same methodology of masterless on the proxy minion, so you wouldn't actually need a master.
Yeah. It's kind of TBD. How
Yeah.
much do you need to scale?
Yeah.
So you might want more than one proxy minion.
Yeah, you can have 100 proxy minions controlling, X number of devices. This is how I know Cloudflare and some other big network orgs, they have one master that spins up as many proxy minions as it needs to talk to its network devices and get them running. So if you have all that logic, like you can just grow exponentially and like everything should just work. Yeah, thanks. Anybody else? Any other questions? Yeah.
When you're making your own modules, do you use something like a cookie cutter to create the framework for it, or are you just making them by hand?
So, like the state module? So that example that I have,
Very much.
it's basically every single one is exactly like that, where you just sub out like what execution module it's calling and like some of the doc strings, so it doesn't look like the other one. But yeah, it's very, they all look the same. Like the more complicated ones, like you clearly have like more functions, you do parameter checks and like all that fun stuff. But at the bottom level, it's very simple.
Yeah, for the most part, state modules are super boring to write because they're all the same, you know.
But the
They just-
execution modules that do all the fun
Yeah.
stuff is a little better. I like them.
Yeah. But yeah, the states are just, is this thing in the state we want it to be in? Are we in testing mode? Okay, change it. You know.
Yeah, that's why I was wondering if you use cookie cutter, since you can have those things
Yeah.
built in.
Yeah. And that way you just don't make any, you don't miss anything.
Cool. Anything else? File. Oh no. Can you sign an NDA first for us? No.
No, sorry for ruining your joke earlier. Really sorry about that. But that's not a question, so here comes a question. So the stuff that, like, from really cool, very powerful stuff that you guys are doing with the MDM, like having MDM do what you want to do, it just feels like it feels like, look like micro MDM is great because it's built for programming, it's built for code. You could tell it to do what you want to do. Has anyone written up a desired asks from a vendor standpoint, from your Workspace ONE or your, whoever? Hey, this is the kind of stuff we'd like to be able to do programmatically in general. It doesn't matter who the vendor is. Has anyone written up like a nice list somewhere of that you could, that if someone had a different MDM or didn't feel they had the technical chops to spin up micro MDM, that they could take to their vendor and go, please, I need this so that I can do cool, powerful stuff with your product in my environment. Has anyone written up something like that?
I have not. Does anybody know? Open question to the room.
If not, maybe
If
that would
not,
be a
yeah,
cool
let's
thing
make
to put
one.
together. Yeah.
Yeah.
Let's make that happen.
yeah.
I mean, I know I routinely
Action items.
I routinely talk to the engineers at our MDM vendor, and they mostly just think we're crazy. So
You want to do what?
They've heard vaguely of this thing called Monkey. They don't really think of it as a competitor. I know.
Engineering chops companies are used to sort of the two-key turn system where there's an approval to get something to happen. And I know a lot of vendor solutions are currently, I have God mode, I made a change,
Yeah.
and uh-oh, I didn't tell the other guy over there that we were going to do that, and now I broke everything.
Yep.
And so to integrate with existing change management solutions that you have and all that kind of stuff, it sounds like the API aspect is really useful.
Yep.
And some of them have APIs, but it just sounds like they're missing some key elements that if someone could get like a nice bullet point list, like we just want this function, and this function, if you could do that, that'd be great.
Yeah, it would be nice if it was actually in the. For the less inclined people, like
but-
also bundled in as well. Yeah.
Sure.
Yeah, I see what you're getting at. I mean, I've definitely looked at other MDMs and said, hey, here's the endpoints we would like to have on our MDM. So.
Oh,
should-
more
we
questions.
should just
Look,
make a-
one, start. Thank
we
you.
should just
You
make a
started the question. We got
manifesto.
2 minutes. Let's go.
Just out of curiosity, I like what I've seen so far. What's the user base of Salt compared to I'm assuming it's not near Puppet, but like-
So I think it all depends on, running particularly on Macs. I know there's a bunch of, it's fairly popular with like iOS CI builders. Actually, like on like Mac admin stuff, I mean, there's a couple of people in the room More and more people like jump into the Slack channel every day and like, oh, this is cool. This like seems way easier than like trying to write Ruby code or something else. Like I know a little bit more Python, or it's just simple YAML files, right? Yeah, I mean, you know, more the merrier. But like in terms of like prod stacks though, I mean, it's huge. There's like at least double the stars on GitHub than like Puppet and Chef. I'm just saying. It's not near Ansible because that's like 50,000 likes or some stuff. But yeah, it's
maybe
crazy.
doing like a POC of it, you know,
Yeah.
my organization. And
I would highly recommend just get all the different ones you're interested in. What I've done, and I've recommended to lots of people, is set up your machine, create states or playbooks, recipes, and set up your machine the way you would like it to, and that gives you a really good, you know, what modules are available, what can I manage with each configuration management. They all do basically the same thing. It just kind of depends on which one you like the best, if you're in the position to make that decision.
Yeah, for us in particular, we found it very easy because like other folks that aren't on our team can look at the states and like, oh, well, that's like pretty human readable. And it's like very easy to like make a change if you wanted to. And we've had like several teams outside of ours that like from engineers, like if you have like a pillar with a list, you can like easily add like one more serial number to it or something. Like you don't have to be a programmer or an engineer to like, you know, contribute to this kind of stuff if you're running it in your organization. And I mean, it's not to say the others can't, but you know, like on that last side, all config managements are great. It's better than nothing. Oh boy.
Do you have any open source third-party modules? And if so, where can we find them?
So I try and put as many as I can on Mosen's repo.
Yeah.
But we're trying a new approach, which is open first, where when we actually write some of these modules, I'm trying to get them into the core product and not just in a third-party library floating around somewhere.
Yeah. And there's some real advantage to that too. Like the standards for submission are much higher for the core products. So
Yeah.
there have to be tests.
But luckily they're like the Salt team, like the core team is they're all fantastic. And even like when you like file a pull request, even for like fixing documentation, they're like, oh my God, thank you so much. Like, and you know, they try and do is get as many changes into the core product as they possibly can.
So
like I had a 5-minute conversation to get PyObjective-C included into the package, and they're like, is the licensing okay? Yeah, cool, let's add it, done.
So one thing I'll mention, I just brought up Mosen's GitHub, and he does have a JSS minion, so that might be interesting to some folks.
Yes, so Mosen, the original creator, or like he was using Salt on macOS years ago and was using PyObjective-C with all this stuff, and nobody seemed to care. And then I found out, I was like, wow, this is actually really cool. And he went to a new job where they like aren't running Salt on the clients, but they're using Jamf. And so he wrote proxy-minions to manage every aspect of Jamf through code like this. Really cool, and that's actually how I got the idea. And I'm like, wait, we can actually probably just like send commands and stuff like that back and forth. But
I feel obligated as should thank everyone for coming. I don't want to keep you going because I know you've all been sitting here patiently and it is break time.
I thought there was supposed to be music.
We will hang out and answer more questions and talk to you, but they need to wrap it up. So
Yep.
You're free to leave.
Find us later. Thanks.